In the echolocating bat study, we've set down this tentative model that the mean log energy as a function of the mass and animal type is some intercept plus some parameter times the log mass of the animal plus beta 2 times an indicator for whether the animal is a bird plus beta 3 times an indicator variable that the animal is an echolocating bat. To understand this model, the easiest way is to write down the model for the mean for each of our animal categories. So let's start off with the non-echolocating bats. In this case, the mean log energy is a function of log mass. We know some of these values. So we know for a non-echolocating bat, it's not an echolocating bat, so the echolocating bat indicator variable takes the value 0. We know it's not a bird, so that indicator variable also takes the value 0. So we can start writing down the mean. We're going to have our intercept plus beta 1 times log mass plus beta 2 times the bird indicator variable, as the value 0, plus beta 3 times the echolocating bat indicator variable, also takes the value 0. So if we were to multiply that out, we'd be left with just a beta 0 plus beta 1 log mass. And we can repeat those steps for the other two categories. So for echolocating bats, the echolocating bat indicator variable will take the value 1, and the bird indicator variable will take the value 0. We'll find we have a beta 0 plus a beta 1 times log mass plus beta 2 times the bird indicator variable. Well, the bird indicator variable is 0, so that entire term is going to disappear. I'm going to take a shortcut and not write it down, but I am going to have a beta 3 times my echolocating bat indicator variable. That takes the value 1. A 1 times beta 3 will give me a beta 3. And then similarly for birds, now our echolocating bat indicator variable is 0, but our bird indicator variable takes the value 1. So we're going to have beta 0 plus beta 1 log mass plus, and then this time we get that beta 2, but we do not get the beta 3. So if we look at these three models for these three categories, we see they all share this beta 0 plus beta 1 times log mass. So they all have a straight line function of the log energy with respect to log mass. The difference being the beta 3 parameter for the echolocating bats and the beta 2 parameter for the birds. So let's take a little bit of a closer look at that. What we're saying is if we think about the plot of the log energy as a function of log mass, all three of our animal types model this as a straight line, and that straight line has slope beta 1. Now the difference between our three models, so remember our non-echolocating bats, they have the mean beta 0 plus beta 1 log mass. And that's it. Our echolocating bats, I'll just say echo, they have the mean beta 0 plus beta 1 log mass plus beta 3. And our birds have the mean beta 0 plus beta 1 log mass plus beta 2. So if we think about a particular value of log mass, just going to call it little x0, we could substitute in little x0 for log mass. And then if we did that, the only difference between these three lines, the first part would all take the same value, but the difference would be whether we're adding nothing, we're adding beta 3, or we're adding beta 2. So for the non-echolocating bats, if this line here is the line beta 0 plus beta 1 log mass, then the mean for a particular value of log mass would lie right on that line. So that line would represent the mean for the non-echolocating bats. If we think about a particular echolocating bat at this particular log mass, it would lie on that line plus this additional beta 3. So if beta 3 is positive, we'd go up beta 3 amount, and our echolocating bat would lie on that line. And that's true for every value of log mass. So that describes a parallel line parallel to the non-echolocating bats, but an additional beta 3 units higher. If beta 3 was negative, then that line would lie beta 3 units lower than the line for the non-echolocating bats. And similarly for the birds, for a particular value of log mass, if there wasn't that beta 2 parameter, they'd lie right on the same line as the non-echolocating bats. If that beta 2 variable is positive, they're going to lie above those non-echolocating bats. So I'm going to draw beta 2 to be quite a bit bigger than beta 3. So imagine if that was the size of beta 2, then our bird would lie up here, and the birds will still lie on a line with the same slope as the other two categories, so I'm going to draw that in. That's sort of our third parallel line. That would be for the birds. I should label this one here. That was for the echolocating bats. So beta 3 describes, for any particular log mass, the difference in mean log energy between echolocating bats and non-echolocating bats. Beta 2 describes the difference in mean for any particular log mass between birds and non-echolocating bats. If I wanted to compare birds to echolocating bats, I'd be interested in the distance between these two lines. I can find that distance if I take beta 2 and I subtract off this distance here, beta 3. So we've got this parallel lines model in this case, and our two parameters, beta 3 and beta 2, describe the distances between our three parallel lines.